So I do have some good news. We don't always have to complete the square to solve my quadratic. There is in fact a much easier way to get the solution of my complex number for a complex quadratic where I have no real roots. And just to reiterate, why we're doing this is because we want to know how to solve quadratics where I don't have real roots. So if I have the determinant of my quadratic is a negative number, we say no real solutions, I now have a way to find complex solutions to my quadratics. That's sort of the bigger idea here. So just like with quadratics, one of the ways I can solve for my quadratics is by using my quadratic formula. It's a very similar idea that I have here for my complex numbers. Which means what this all kind of leads to, or what this builds to, is being able to use my quadratic formula. My quadratic formula, if we remember, is minus b plus or minus the square root of b squared minus 4ac all over 2a. Now, normally it's x is equal to this, but my variable in these equations is my complex number z, so I'm going to say that z is equal to this quadratic formula. If I use that on my current complex quadratic, I can find solutions to my complex quadratic without having to do all the factorization stuff. So in this case, a is my coefficient of z squared, b is my coefficient of z, and c is my constant on the end. So if I put all of these numbers into my quadratic formula, I'm going to get z is equal to minus 8 plus or minus the square root of, in this case, it's going to be negative 8 squared minus 4 multiplied by 3 multiplied by 6. Let's extend that out. All over 2 times 3. That is going to be equal to negative 8 plus or minus the square root of, if I crunch my numbers here, I'm going to get negative 8 over 6. Well, negative 8 is going to be the square root of positive 8 times the square root of negative 1, which is going to be the square root of 8i. Okay, so if I scroll down to give myself a little bit more space, that is going to give minus 8 plus or minus, well, the square root of negative 8 is the square root of positive 8 times the square root of negative 1. The square root of negative 1 is I, so it's just going to be the square root of 8i, all over 6. If I simplify things out a little bit into a real and into a imaginary component, that is simply going to equal negative 8 divided by 6. Okay, again, if I give myself, I'm just going to give myself a lot more space here. If I simplify my quadratic solution here into both a real and a complex part, that is going to give negative 8 over 6 plus or minus the square root of 8 over 6 lots of I. If I simplify my fractions, negative 8 over 6 is simply just going to be negative 4 over 3, plus or minus, well, the square root of 8 is going to be 2 root 2 over 6i. And simplifying 2 over 6 here is going to give negative 4 over 3, plus or minus root 2 over 3 lots of I. So, therefore, z is going to equal negative 4 over 3 plus root 2 over 3i, and z is going to equal negative 4 over 3 minus root 2 over 3i. These are my two solutions for my complex quadratic. Again, no factorization required. If it just says solve, use quadratic formula, work through and solve. That's going to be the easiest way, I think, to get your solution to any complex quadratic.